Hello, ninth graders! This is the Teleradyo Eskwela. Tara na! Welcoming you to Mathematics 9. We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your Teleradyo host, Teacher Ms. Pajen M. Campo from Tagum City National High School. Are you all excited to learn? That is great! And we would like to thank our radio partner, Hope Radio 107.1 DXHS, where we are airing episodes for junior high school. Thank you for your generosity. Come and join us and be one of a kind Math Talino student. Before we begin, I would like you to get your modules, your notebook, and your pen, and be comfortably seated in the comfort of your homes. Our topic for today will be deriving the laws of radicals. This topic will be brought to us by our Teleradyo teacher, Teacher Anabelia U. Amodia from Tagum City National High School.
Hello, dear students. Now that you are all settled in your homes, bring out your pens and notebooks and our learning module. Specifically, your Mathematics 9, Quarter 2, Module 6. Here are our objectives for today. At the end of the lesson, you should be able to derive the product, quotient, and power rule for radicals based on the laws of exponents, which is rational, and solve basic problems involving laws of radical expressions with rational exponent to radical expression. Before we begin the formal lesson, let us have a review on how to transform the given exponential form into radical form and radical form into exponential form. I will present to you the given expressions and try your best to answer correctly. You will be given 5 seconds to answer. Rewrite quantity 9 raised to the power of 1/2 to radical form. You have 5 seconds to answer. Time is up. The correct answer is square root of 9. The correct answer is square root of 9. Number 2. Rewrite quantity 1/4 a squared raised to the power of 1/3 to radical form. Rewrite quantity 1/4 a squared raised to the power of 1/3 to radical form. You have 5 seconds to answer. The correct answer is cube root of quantity 1/4 a squared. Cube root of quantity 1/4 a squared. Third question. Rewrite square root of 64 to exponential form. Rewrite square root of 64 to exponential form. 5 seconds starts now. The correct answer is quantity 64 raised to the power of 1/2. Quantity 64 raised to the power of 1/2. And the last number is number 4. Transform quantity the fourth root of 24xy raised to the power of 5 to exponential form. Transform quantity fourth root of 24xy raised to the power of 5 to exponential form. 5 seconds starts now. The correct answer is quantity 24xy raised to the power of 1/4 and raised to the power of 5. The correct answer is quantity 24xy raised to the power of 1/4 and raised to the power of 5. Did you get all the correct answers? Great! You are now ready to proceed into the next part of our lesson. This time, we will be working with deriving the laws of radicals. Understanding the different laws of radicals is important because it helps us to simplify and perform the different operations of radicals. Let us find out the rule number 1. In the laws of radicals, the quantity nth root of a raised to n, rewrite this expression to rational exponent, which is the quantity of a raised to 1 over n and raised to n is equal to a raised to n over n is equal to a. So therefore, the nth root of a raised to the power of n is equal to a. Number 1. Simplify square root of 36. Rewrite the expression to rational exponent, which is quantity 6 squared raised to the power of 1/2, and that is equal to 6. Number 2. Simplify. Negative 2 times the square root of 25. The rational exponent is negative 2 quantity 5 squared raised to the power of 1/2 is equal to negative 2 quantity 5 to the power of 2 over 2, which is equal to negative 2 quantity 5 is equal to negative 2 times 5, which is equal to negative 10. So therefore, the simplified form of negative 2 times square root of 25 is equal to negative 10. The next rule is the nth root of a raised to m. Rewrite the expression to rational exponent, which is equal to a to the power of m over n is equal to quantity a to the power of 1 over n raised to m. Then rewrite again to radical expression, which is quantity the nth root of a raised to the power of m. Examples. Simplify. Fifth root of y raised to the power of 4. Again, rewrite the expression to rational exponent, which is equal to y raised to the power of 4 over 5. And that is equal to the radical expression, which is quantity to the fifth root of y raised to the power of 4. Example number 2. Simplify. Cube root of 27 squared is equal to rational exponent, which is 27 raised to the power of 2/3 is equal to quantity the cube root of 27 raised to the power of 2, which is equivalent to radical form. And again, the simplified form of the quantity cube root of 27 squared is equal to 3 squared, and multiply 3 twice, that is equal to 9. So therefore, the cube root of 27 squared is equal to 9. Rule number 3. The nth root of AB. Rewrite the expression, which is quantity of AB raised to the power of 1 over n is equal to A raised to 1 over n times B raised to the power of 1 over n. In radical form, that is equal to the nth root of A times the nth root of B. The rule says, if A and B are real numbers, then the nth root of AB is equal to the nth root of A times the nth root of B, and n is greater than 1. Let's try this example. Simplify. Square root of 32. Find the factors of 32 in which one of the factor is a perfect root and the other is not. So the factors are the square root of 16 times the square root of 2. And the answer is 4 times the square root of 2. So the simplified form of the square root of 32 is equal to 4 times square root of 2. Can you still follow, class? Great. Let's now proceed to example number 2. Simplify. The square root of 12 x cubed y to the 5th power. Find the factors of 12 x cubed y to the 5th power, in which one of the factor is a perfect root and the other is not. So we have the square root of 4x squared y to the 4th power times the square root of 3xy is equal to the square root of 2 squared x squared to the 4th power times the square root of 3xy is equal to 2x squared times the square root of 3xy. So the simplified form of the square root of 12x cubed y to the 5th power is equal to 2xy squared times the square root of 3xy. Simplify group of perfect nth root by dividing its exponent with the index. Rule number 4. The mth root of the nth root of a, which is the power rule of the radical. The mth root of the nth root of a is equal to the mth root of a raised to 1 over n is equal to the quantity of a to the power of 1 over n raised to the power of 1 over m is equal to a raised to the power of 1 over mn and equal to the mnth root of a. Let's try this example. The square root of the cube root of 64. Multiply the indices 2 and 3. So we have the 6th root of 64 is equal to the 6th root of 2 raised to the 6th power, and the root is 2. So the simplified form of the square root of the cube root of 64 is equal to 2. Number 2 example. The 4th root of the cube root of 16a to the power of 8 is equal to the product of the 4th root and the 3rd root of 16a to 8 power. You can interchange the index as long as you can find the perfect root of the radicand. So we have the cube root of the 4th root of 16a to the power of 8, which is equal to the cube root of the 4th root of 2 raised to the 4th power, a to the power of 8. So the simplified form of the 4th root of the cube root of 16a raised to the power of 8 is the cube root of 2a squared. Now that you have learned to derive the product and the power rule for radicals, we will now proceed to the second part of our lesson, which is deriving the quotient rules of radicals. Let us try to check if you already know about the lesson. Example number 1. Simplify. Square root of 25 over the square root of 16. You have 20 seconds to answer. The correct answer is 5 over 4. Very good. Let's now proceed to example number 2. Simplify. Cube root of 27 over x to the power of 6. Simplify. Cube root of 27 over x to the power of 6. You have 20 seconds to answer. The correct answer is 3 divided by x to the power of 2. 3 divided by x to the power of 2. To divide radicals, we have steps to follow. Number 1, ensure that the index of each radical is the same and that the denominator is not 0. Number 2, convert the expression to one radical. Number 3, simplify where possible. Number 4, rationalize the denominator if necessary. What do you mean by rationalization? It is the process where you can simplify the expression by making the denominator free from radicals. Quotient rule. The square of a quotient is the quotient of the square roots. So if A is greater or equal to 0, B is greater or equal to 0, then the square root of A divided by square root of B is equal to the square root of A over B. To divide radicals of the same order, use the property nth root of A over the nth root of B is equal to the nth root of A over B. For all real values A and B, where B is not equal to 0. If n is even and A is greater or equal to 0, B is greater or equal to 0, then the nth root of A over B is equal to the nth root of A over the nth root of B. Number 2, if n is odd and B is not equal to 0, then nth root of A over B is equal to the nth root of A over the nth root of B. To divide radicals of different orders, it is necessary to express them as radicals of the same order, then rationalize the denominator. Quotient rule for radicals. Quantity y over 9 raised to the power of 1/2 is equal to y to the power of 1/2 over 9 to the power of 1/2, which is equal to y to the power of 1/2 over 3. And quantity 3 over 32 raised to the power of 1/5 is equal to 3 raised to the power of 1/5 over 32 raised to the power of 1/5, which is equal to 3 to the power of 1/5 over 2. These equations can be written using radical notation. Square root of y over 9 is equal to the square root of y over the square root of 9, which is equal to the square root of y over 3, which is the square root of 9 is equal to 3. And the fifth root of 3 over 32 is equal to the fifth root of 3 divided by fifth root of 32, which is equal to the fifth root of 3 over 2, since the fifth root of 32 is equal to 2. The power of a quotient rule is also valid for integral and rational exponents. The power of a quotient rule for the power of 1 over n can be stated using radical notation. When written with radicals, it is called the quotient rule for radicals. The quotient rule is used to simplify radicals by rewriting the root of a quotient as the quotient of the roots. Let's try this example. Simplify cube root of 3 over the square root of 3. Rewrite to rational exponent, that is 3 to the power of 1/3 over 3 to the power of 1/2. To have a common index, find the least common denominator between 3 and 2, which is 6. So, the expression is 3 raised to the power of 2 over 6 over 3 raised to the power of 3 over 6. Then, expressed to radical form, that is the 6th root of 3 squared over the 6th root of 3 cubed. Rationalize the denominator so that the denominator will be free from radical. So the product is the 6th root of 3 to the power of 5 over the 6th root of 3 to the power of 6, which is equal to the 6th root of 243 over 3. So the simplified form of cube root of 3 divided by 3 is equal to the 6th root of 243 over 3. Number 2, simplify the square root of 4 over 25. That is equal to the square root of 4 over the square root of 25. So the answer is 2 over 5. A radical expression is in simplest form if it satisfies the following conditions. Number 1, there is no perfect square in the radicand. Number 2, there is no indicated operation in the radicand. Number 3, there are no radicals in the denominator of a radical fraction. And number 4, there is no fraction in the radicand. That ends our lesson for today. At this point, please prepare your quiz notebook and your pen. Focus your attention and be ready for our assessment. I will be asking 3 questions for the test. There will be no choices, so you have to be quick in providing the answer. Are you ready? Let us begin. Number 1, simplify. Square root of 81c to the power of 4. Simplify. Square root of 81c to the power of 4. You have 20 seconds to answer. The correct answer is 9c squared. Next, number 2. Simplify. Cube root of the square root of 27a to the power of 15. Again, simplify. Cube root of the square root of 27a to the power of 15. 20 seconds starts now. Time's up. The correct answer is a squared times the square root of 3a. The correct answer is a squared times the square root of 3a. Let's now proceed to question number 3. Simplify. Cube root of 27a to the power of 9 over 8b to the power of 6. Again, cube root of 27a to the power of 9 over 8b to the power of 6. You have 20 seconds. The correct answer is 3a cubed divided by 2b squared. 3a cubed divided by 2b squared. For your assignment, answer, let us enhance of your Quarter 2, Mathematics 9, Module 6, Lesson 2, page 13. Kindly write your answer in your notebook for checking at the times set in the weekly home learning plan. That's all for today. Stay tuned next week for a discussion on simplifying radical expressions using laws of radicals. Let us turn you over now to Teacher Mispa. Until next time.
Thank you, Teacher Annabelia. That ends our lesson for today. For you to understand our topic further, you may do the exercises provided in your modules. You may also have an advanced study of your topics to prepare yourself for your next lesson. Remember that the key to mastering mathematics is constant and diligent practice. Please make sure to be with us next session here at the School on the Air program of the Department of Education, Tagum City. This has been Teacher Miss Pajan M. Campo, your Teleradyo host. Keep safe, everyone!
TV High, dito sa City High. Makisabay, matuto't maglakbay sa TV High.